The process of finding the derivative is called a differentiation. Just the process. Okay. Right. In this case also, see, a differentiation actually is depending on differentiability. Differentiability. That's we know that here f dash of x is equal to limit h tends to 0. Okay, f of x plus h minus f of x by h. Okay, in this class I am going to explain you complete concept. Next class we will start classwork 2. Okay, classwork 2. And then, so here f dash of x is exist. It should be exist nothing but already we have seen the f dash of x value must be finite. So it is exist finitely. Okay. So here f dash of x is exist. It should be a finitely. So here this is also can be written as dy by dx. This is also can be written as f dash of x already we written df by dx. Okay. So on like even we'll write this one as y dash and y suffix what I already told you. Okay, like that. And this is equal to delta y. Delta y. Right. Okay, next already we have seen that the difference, some are difference rules. Nothing but here dy by dx. What is the mean by dy by dx? The rate of change of y with respect to x. If I take any two quantities, okay, like yb, the actually the derivative of a dependent variable with respect to independent variable is called the derivative. Here x comma y are any two quantities. The rate of change of quantity y with respect to the quantity x is denoted by dy by dx. Many examples are there. Okay, temperature of the body or number of population is increasing with respect to time. The population is one quantity with respect to time. Time is another quantity. Okay, the natural growth or decay will be there. Okay, so here dy by dx. So in all the questions we need to find dy by dx or else d square y by dx square. This is called the second derivative of y with respect to x, and d cube y by dx cube. So here dy by dx alone, the first order derivative. This is called first order derivative. How many times we differentiated here? Only one time. Only one time. Okay, this is called first order. So remaining like from second order to till some final differentiation is called higher order. Okay, more than one differentiation is called higher order derivatives, right? So like a given function maybe y is equal to f of x, that we know that this is called explicit function. Okay, explicit function. And if f of x comma y is equal to 0 or some c constancy, this is called, we already discussed that this is implicit function. So already we discussed all these things in NCERT. Okay, explicit function. Like examples, we can give many examples for this. Like y is equal to f of x means y is equal to x square, y is equal to sine x, y is equal to e power x, y is equal to log x. So these are all explicit function. And implicit functions means, for example, here we can see here sine of xy is equal to some x plus y, or x square plus xy plus y square is equal to some 2. Like say, can you able to write these functions in the form of y is equal to f of x like this? It is highly impossible. We cannot separate y one side remaining x terms on another side. So this is called just implicit function. So above examples are explicit function. Then how to differentiate this implicit function, explicit function? So already we discussed, okay. So in all the cases, simple, differentiate on both sides with respect to x. Okay. So whatever we discussed in fifth chapter, that is completely related to differentiation alone. Differentiation alone. The derivative of like inverse trigonometric functions also we discussed. Okay, like so we will discuss here more briefly in objective. Okay, some are difference rules. First, I'm going to write three rules that already we discussed, that d by dx of. So here let us take f is equal to f of x comma g is equal to g of x, or any two different functions. Okay, like y is f is equal to f of x, maybe I'm taking sin x. G is equal to g of x, I'm taking e power x, or x, or log x, whatever it is. If we are having two different functions, the derivative of d by dx of f plus g, this is called addition rule. Addition rule, adding. And if I take minus, this is a difference rule. Addition or sum rule or difference rule is can be written as, just we can write separately, d by dx of f plus d by dx of g. This is sum rule. If I take minus, this is difference rule. And the second one is the product rule. Product rule means UV formula. D by dx of, already we seen UV. UV, instead of UV, I'm taking F into G. That's all. So this is clearly equal to F into U into V dash. That is dg by dx plus g into df by dx. This is called a product rule. Why? A product of two different functions, a sum difference of two different functions. Okay. Right. Next one is quotient rule or division rule. That is in the sense u by v rule, u by v formula. So d by dx of f by g, u by v is equal to, first what is the formula? V u dash. If I comparing u by v, g d by dx of f minus f dg by dx by g square. So just I have written known, already these are known formulas, right? Chain rule also already we discussed that. What is the mean by chain rule, student? Chain rule means uh, that already we discussed, like some y is a function in terms of v is a function in terms of u is a function in terms of x something. Already we have seen that. Like I'm going to take like this chain rule. This chain rule can play very important role in differential calculus. Am I right? Okay. So chain rule, right? If I take y is a function of y of like take any variable, that's your wish. Y of u, and u is a function in terms of v is a function in terms of t is a function in terms of x. I have written like this. Okay, here y is a function in terms of u, and u is a function in terms of v is a function in terms of t is a function in terms of x. Finally, I want to find dy by dx. Okay, in every question we need to find dy by dx. So for that, first dy by u is a function in terms of u, so dy by du. And again, u is a function in terms of x. No, u is a function in terms of clearly v. Again, v is a function in terms of t. So now you can differentiate y with respect to u. We are going to get this. Differentiate y with respect to u. We'll get dy by du. Here u is a function in terms of v, so that differentiate u with respect to v. V is a function in terms of t. Differentiate v with respect to t. Finally t is a function in terms of x. So finally we got it dy by dx. Okay, I already clearly told you that even we can cancel this. If we cancel this, dt cancel, then finally we'll get dy by dx. So dy by dx I have written like this. This is called the chain rule. Okay, this is chain rule, important. And after a chain rule, that we know some basic formulas, standard formulas. Already you know that the derivative of constant, derivative of x, derivative of e power x, everything. Okay. Derivative of basic elementary function we will discuss. That is d by dx of. I'm asking few formulas. Can you tell me that what is the derivative of log x? Base e. Yes, anyone? 1 by x. What is the derivative of log x base a? Base e, base a. Now, twins. Yes. Actually, here it is 1 by x log a, base a. Because here actually log e value is 1. So remember that. So you should observe the base first. Log e value is 1, so that no need to write here log e. Simply we'll write 1 by x. It is not always 1 by x, depending on the base. Okay, fine. So what is the derivative of students? Next, for example, d by dx of a power x. A power x are some, I want to take 100 power x. Anyone? What is the derivative of 100 power x? 100 power x into log 100. Okay, nothing but it is in the form of like a power x. A power x is a power x into log a. Is it clear? So a power x may be 100 power x, 2 power x, 3 power x, whatever it is. Right? So with alpha of here, how to differentiate actually with alpha of logarithmic method? Logarithmic differentiation, we see if I take y is equal to a power x, I want to differentiate, apply log on both sides. Log y is equal to log a power x, right side is log a power m log a, log y. Now differentiate here. When I differentiate here 1 by y, again y is dy by dx is equal to x derivative. X derivative is 1. 1 into log a. Okay, should not apply any UV rule. Log a is a constant. So it is in the form of 2x. 2x is 2. Log a into x, log a. So now cross multiply dy by dx is equal to y into log a. What is again y? A power x into log a. Like that. With help of logarithmic method, we'll find the a power x derivative. Even here log x base a also like that. Log x base a, we can apply log a by b form. Log a base b. Log a base b can be written as log a by log b. Log a by log b. So in this case, what will happen? Base becomes e. When you write log a base b, if you write like this form, so base becomes e. Now log a is, now you can differentiate here. So in place of a here we are having different values. So what is the question I'm taking? Function I'm taking log x base a. Log x base a. Here x base a. So now log x derivative, as you said, 1 by x. Log a is as it is. So that log a. Like that we'll get. Log a will get in denominator. Like that you should have some idea about this, how to get a power x derivative is like that. If you have idea, it's no problem. Okay, students. Right. Next, some d by dx of like 1 by x is there. I told you 1 by x is minus 1 by x square, and the d by dx of like root x will be there. Root x derivative is 1 by 2 root x. Okay, and after that we know that the derivative of sin x cos x. Shall I write the derivative or else not required? Trigonometric function derivatives. Is it required? Okay, I think so. Not required. Derivative of sin x is cos x. Cos x is minus sin x. Okay, tan x is clearly secant square x. Okay, cot x will be minus cosecant square x. Okay, secant x will be secant x tan x. Derivative of secant x is secant x tan x. And cosecant x is minus cosecant x cot x. Okay, remember these formulas because the derivative means the integral of this inverse process can play very important role. If you remember derivative formulas, then integration becomes easy. Okay, these are the derivative, and I told you shortcut method to remember this. When input is c, output we are getting negative values. Some student might be confusing here. See, for what function we are getting output is negative value. Derivative of c, cos means starting is c, cot means c, cosecant means c. So in these three cases, we'll get output is negative. Okay, so remaining and all sin x minus cosecant square x. So we can easily remember that. Okay, right. Next, these are the derivative of trigonometric, and especially remember inverse trigonometric function. So a derivative of the trigonometric is very easy to remember, but the students can confusing to remember derivative of inverse. Sin inverse x, okay, should be equal to derivative of minus cos inverse x. So derivative of sin inverse x should be equal to derivative of minus cos inverse x. That is equal to 1 by root over 1 minus x square. Clear, students? And next one is the derivative of tan inverse x should be equal to the derivative of minus cot inverse x. Okay, it's equal to what is 1 by 1 plus x square. Both will be same, right? And the third one is the derivative of d by dx of secant inverse of x should be equal to derivative of minus cosecant inverse of x. That is equal to what? 1 by modulus x root over x square minus 1. X square minus 1. So can we prove this? Yes, we can easily prove this formulas. Sin inverse x derivative, cos inverse x derivative. Okay, by substitution method, take y is equal to sin inverse x, then x is equal to sin inverse. After that, differentiate with respect to x. Left side is 1, right side is sin y is cos y into again dy by dx. That we can convert. Finally, we'll get 1 by root over 1 minus x square. Okay, so simply remember what is the derivative instead of the derivative part. Try yourself, no problem, we'll get easily answer. No doubt in that case. Yes or no? Getting any doubts, you can ask. Sin inverse x is equal to like y I am taking. Okay, then x is equal to sin y. Now differentiate here with respect to x. 1 is equal to cos y into dy by dx. Okay, we require dy by dx only, no? This is the dy by dx value. So here dy by dx value is equal to 1 by cos y. Cos y, we don't know cos y. I am taking like sin inverse x as sin y, but we don't know cos y. Sin y is x. Do you know cos y? No. So you can convert it into in terms of sin y. So we'll write like that: 1 minus sin square y. So no, cos y can be written as root over 1 minus sine square with help of sine square x plus cos square x is equal to 1 with help of that standard formula. Right, students? Okay. Then after this sine y, what is sine y is? Sine y is clearly x. Yes or no? Sine y is x. So replace x by sine y. So we are going to get 1 by root over 1 minus x square. See, got it? 1 by root over 1 minus x square. So what I'm saying is, as a JE student, you should know, you should have some idea about why, how we got that derivative of sine inverse x as root over 1 by root over 1 minus x square. Like that, even you can do the remaining also by equating to y or t something. Okay. The next, see, it is very easy to remember again. See, student, what do you observe here? Starting with cos inverse means C, cot inverse means C, cosecant inverse means C. So this value, if I take minus right side, what is the output? We are going to get here d by dx of cos inverse is minus, d by dx of cot inverse is minus, d by dx of cosecant inverse is minus. Nothing but when the input is given as C, again here also same, we are getting output is negative. Is that clear? So instead of writing all separately, I have written together sine inverse, cos inverse, like that. Okay, like that shortcut way you can remember. And coming to hyperbolic functions are there. So hyperbolic functions, that is, sine hx value is e power x minus e power minus x by 2. Then what is the derivative of d by dx of sine hx? Sine hx will be clearly cos hx. In the same way, cos hx derivative is, value is e power x plus e power minus x by 2. Everyone should remember. So after that, tan hx is clearly sin hx by cos hx, that e power x minus e power minus x by uh, e power x plus e power minus x. So once we know that sin hx and cos hx, remaining hyperbolic function we can easily write in terms of e power x. Okay, students, we can easily write remaining functions. Fine. So like that. Okay, so the derivative. So d by dx of then cos hx will be sin hx. Okay, what is the d by dx of tan hx? Will be secant square hx. So in the same way, remaining three. Remaining three are d by dx of cot hx will be minus cosecant square hx. D by dx of secant hx will be minus secant hx into tan hx. So d by dx of finally cosecant hx will be minus cosecant hx cot hx. I think in master G synopsis, almost all formulas are given. Once you can go through that. Okay. See, what do you observe in this case? Whenever it is a hyperbolic function h, yeah, this h will represent a hyperbolic function. When you see h here, it is a hyperbolic function. Okay, so in hyperbolic function, sine, cos, tan. Generally in trigonometry, cos will be negative, but in hyperbolic it is positive. In trigonometry, secant hx will be negative, but in hyperbolic function it is, positive. Here it is negative. Trigonometry it is positive, but hyperbolic is negative. The first three are positive, next three are negative. Is that clear? So the derivative of inverse hyperbolic functions also there. Sometimes, yeah, mainly everyone can remember up to here. Like even they can easily remember this inverse trigonometry also. But most of the students, they can not remember that the derivative of inverse hyperbolic functions. Inverse hyperbolic functions that are very, very like important to remember. So first I'm going to write d by dx of sine h inverse of x. Okay, here also we can prove that these values by the sine h inverse of x equating to y. You can equating to y. Okay, you'll get. So what is the derivative of this sine h inverse x? 1 by square root of 1 plus x square. See, sine inverse is 1 minus x square, but whereas sine h inverse is 1 plus x square. And the next one is d by dx of cos h inverse of x is equal to, okay students, same here, but whereas we are going to take like a minus 1 x square minus 1. Here x square plus 1, x square plus 1 is sine h inverse x. Cos h inverse x, simply it is just minus. What is d by dx of tan h inverse of x? What is the tan inverse x? 1 by 1 plus x square, but here 1 minus x square. That's all. See, sine inverse is negative, sine h inverse positive, tan inverse is positive, tan h inverse is negative. So like that, remaining value. Cot h inverse of x, d by dx of secant h inverse of x, d by dx of cosecant h inverse of x. Okay. So what about here, like cot h inverse of x here? Yes. Minus 1 by 1 minus x square. Okay. Secant h inverse is like minus 1 by modulus x. Secant inverse is x square minus 1, here 1 minus x square. So here the answer is like cosecant h inverse of x is minus 1 by same modulus x root over. Here whenever secant is 1 minus x square, this is 1 plus x square. 1 plus x square. Okay, students? Like that. Right. So these are the derivatives of inverse hyperbolic functions. Okay. So just try to practice this inverse hyperbolic alone. Next, that already we have seen the determinant. Determinant, the derivative of 3 by 3 determinant, 2 by 2 determinant. Okay. So then logarithmic differentiation, that and all. Okay. The problems are very, very easy, man. Don't worry about that problems. Like whatever the question you can take here. Differentiations here, and few formulas will be there actually to remember. For example, sometimes a UV rule they may apply. For example, d by dx of, for example, sine power nx into sine of nx will be there. Like power will be same, your coefficient, x coefficient is same, power will be same. n, 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 n. Okay. So in this case, power n, here n. So in this case, the answer will be, yeah, differentiate this sign for n sine power n minus 1 x into a sine nx becomes sine of n plus 1 into x. Whereas d by dx of cos power nx into cos nx. is given by n cos for n minus 1 x into cos of n plus 1 into x, but here it is negative because cos derivative is minus I. Like that, finally the output will come like this. Okay. So see the questions when you see, especially student, you must practice classwork 1, homework 1, because it's subtopic wise they given question. In classwork 2 is not like that. Sometimes they may not be give all subtopics in classwork 2 and homework 2 as well as level 3. Level 3 they don't mention mostly. Here if you observe that level 1.
So can you show the slide once?
Sorry?
So can you show the formula that you written, sir?
What I have written?
Yes, 1 minute, sir.
Yeah, sure.
Thank you, sir.
Right. And already here also already we have to discuss the parametric differentiation. Okay, next class we will start the problems. So because you can see here formula based. First one is in exercise 1 class 1. First few questions which is belongs to formula based, directly formula. And next one is inverse trigonometric and substitutions method and logarithmic differentiation. Derivative of hyperbolic and inverse functions. Hyperbolic and inverse and parametric differentiation and derivative of one function with respect to another function. This is very easy actually. Okay, and derivative of implicit function like that. Okay, here also same logarithmic differentiation, derivative of hyperbolic and inverse functions, derivative of one function with respect to another function like that. So parametric means, as we seen in previous classes, x we can represent, x is a function in terms of t, like f of t, and y is a function in terms of t. Here t is a parameter. Then dy by dx is given by dy by dt by dx by dt. That's all. This is only one formula. This is parametric differentiation. Okay, parametric differentiation, right? So like that, it may be sometimes they may ask second derivative also. After finding dy by dx, they may ask second derivative, that we will see in questions. And already we have seen differentiation of implicit function and explicit function, and derivative of composite functions also there. Sometimes they may give composite functions. See in
Sir, 1 minute,
functions.
can you scroll up, sir?
Sure. I think we completed this composition function concept for Master G. I think so. Non-Master G, they're planning to discuss composition function, inverse function later, after completion of volume 1.
Thank you, sir.
Yeah, right. Then composite function means, as we say, like f comma g are any two functions. The composition of these two functions can be written as f circle g or g circle f. Okay, if I take y is a function in terms of x, means f circle g of x, and y is a function like may g circle f of x. Now, how can you differentiate here? So this can be written as f of g of x. This can be written as g of f of x. See, students, I want to do one thing. I want to differentiate this function alone. I want to differentiate. So dy by dx of this function is given by first. Here we can apply the chain rule. First you can differentiate f, then after you can differentiate g. So f dash of g of x as it is into g dash of x. This is the derivative of composite function f circle g. In the same way, g circle f is dy by dx is equal to first g dash of f of x into next bracket, and bracket f of x is there, f of x derivative f dash of x. Already we have done one problem in differentiability, and I think one previous year questions with help of this. This is the derivative of composite functions. Okay. So next some standard derivatives are there. Okay. And logarithmic derivative means already we have complete idea about logarithmic differentiation. When the given function, given variable y is function power function. Function power function, apply logarithmic. Function by function, we can apply u by v rule, or else logarithmic method also we can apply. Or else function power f of x power g of x power h of x power, like some it's going on, some finite values are there, then we can apply logarithmic method. And function by function, like f1x, f2x, f3x, so fnx by g1x, g2x, so on, gnx. Nothing but see here, the function in the form of product of some finite functions by product of some functions, different functions. So in that case also you can apply logarithmic method. Okay, so logarithmic differentiation. This kind of functions we can apply log on both sides, then only you can differentiate. You'll get answer easily. Okay, students. So